Hello, Year 6. Welcome to my video about speed. Speed is all about how fast you can go. And it's much easier like this. But how fast you go. Okay, how fast you go. We know that. We see speed all the time. We see it in cars, we see it in all transport. We can measure it anything we do. But to actually measure it is quite hard. I can't watch somebody and see how fast they are. I can't tell you, oh, that car's 30 miles an hour or 40 kilometers. I can't see that. But I can measure speed if I measure two different things. I need to measure the distance. I need to see how far they are going, how far they travel. I need to see that if I'm going to be able to work out any speed. And I need to see the time. I need to see how long it takes them to do that. Now, we might have seen many different things for speed. In the car, you may see miles per hour, or because most of you are Swedish, you are probably likely to see kilometers per hour. And the numbers in the roads in Sweden are in kilometers per hour. They tell you the maximum speed you can go at. How I work out the speed is quite simple. Speed equals the distance divided by the time. So let me take a very simple example. Let's have somebody run a 100-meter race. Distance, 100 meters. And they do that in 10 seconds. Now, 100 divided by 10, take my zeros away, that gives me 10 meters per second. You may also see that written as ms, 10 minus 1 possibly. This here, that is my speed. 10 meters every second. It's true. I could maybe have different numbers. Let's say, Mr. Robertson, now I'm not very fast. So maybe I can do, I know, I did a 10-kilometer run this year. I did 10 kilometers. And I did 10 kilometers in a little bit under 50 minutes. 10 divided by 50, that means I was doing 0.2 kilometers per minute. And if I want kilometers per hour, all I do is multiply by 60, because minutes times by 60 will give me my hour. But I did 0.2 kilometers a minute, 200 meters every minute. Not too bad. It's okay. And that's how fast I am when I did my 10k. That's how we calculate speed. And all of this here, I can write this like a triangle. I can write it as distance, speed, and time. Some questions might give me, I need to find the speed, so I do distance divided time. If I need to find the time, I would do distance divided by speed. And if I need to find distance, I do speed divided by time. Simple. However, speed is not quite as simple as that. Let's take Usain Bolt. Usain Bolt has a world record of something around 9.57 seconds now for his 100 meters, I believe. Now, if I did my distance 100 divided by 9.57, it's around 10.5 or something meters per second. Now that's true, but Usain Bolt is faster than 10.5 meters per second. Much faster. We have to remember it takes time for him to accelerate. If here's Usain Bolt doing his 100 meters, he starts here. And then the time starts at the same time the gun starts. He waits a bit, and then he hears the noise, and then he goes. But his first few steps are slower, and then he speeds up and speeds up and speeds up throughout the race. Usain Bolt is accelerating. He is getting faster and faster and faster, accelerating. After the race, he decides to slow down again. He is decelerating. And it's that balance between accelerating and decelerating that means Usain Bolt is actually faster than that, much faster. Usain Bolt will be hitting 13, 14 meters per second quite easily by the end of his 100 meters. It takes people in the 100 meters about 60 meters to get to full speed. So you have accelerating, you have decelerating. You have different ways of measuring speed. And I will ask you this week to calculate some of those. I would not ask you to calculate any of them for a test, but I may ask you to understand why we have, if the distance is smaller, why is the speed going to be smaller or bigger in different situations, using our forces knowledge too. And of course this happens for people who jump out of planes. And those people that jump out of planes go slowly at first, and then they go faster and faster. Here they are accelerating, and they go faster and faster. As they go faster and faster, remember the forces. So here at the start, there's gravity pulling them down. But then as they go faster, there's going to be more and more air hitting. So as we go further down, there is more air resistance. They still go faster, but then they get to a point where they can't go any faster. Because at this point here, our skydiver, the gravity equals the air resistance. So still going, but can't go any faster. So going down, whee, and then at this point, got to open up a nice parachute. That parachute, the gravity is still there, but the air resistance is much bigger. So they start to get slower. So they get even more air resistance, and then they decelerate. They don't go backwards, they just go down slower. And then, as they go slower, they meet less air again, and we get to a point at a nice slow speed where the gravity and air resistance are equal, and we nice and safely come to the ground, like so. This is an idea of a phrase that's called terminal velocity. The terminal velocity is your maximum speed. It's the top speed you can do. Every car, every train has a top speed where their forward forces are equal to their backward forces. No matter how much you run, no matter how much you put your foot on the accelerator, no matter how far you fall, there's a maximum top speed. That is called terminal velocity. That is the end of this video. Stay safe.